Okay, in the last two videos, we looked at just a standard wave function, where you were rewriting your sine and cos addition as a wave function, and then you were setting that wave function equal to a number, and then solving. Okay. So that was our last two examples. I was doing another one, and I thought, you know what, I'll just go into this next skill because they are very similar. I think two is maybe enough. And this is, again, very similar. So we're going to express a sine and cos as a wave function, so exact same as what we did before. And then we're going to find the minimum value and where that occurs. So it's a wee bit, it's similar. It's very similar. Okay. So first thing I'm going to do is do a wave function, and again, I'll just go through that. Feel free to pause the video. I'll be quite quiet, which I'm sure you'll be happy about. just going through the motions. Okay, so let's do our wave function first of all. Okay. I'm going to expand. So remember, when you've got the cos, the sign changes. Don't make that mistake. And I forgot a wee k in there as well. And I'm just at this point moving the sine alpha to the front, and I'm moving the cos alpha to the front. I'm not moving the x's and the alphas around. I'm moving the whole cos alpha and the whole sine alpha to the front. So this is kind of a times b times c, and now I'm writing a times c times b. Okay, I'm not changing x and alpha, I'm moving the whole thing around. And then I'm going to equate. It can always be quite relaxing this, because it's, like I said, it's very similar each time. Take away, and I'll call that 1 sin x. Okay, so this is our first one. It's a little bit different. So right now the cos x's match up, so I'm thinking brilliant. That is going to give me 2 is k cos x, but my signs here don't match up. To make them match up, I can say, I'll keep that as an add, take away negative 1. If I'm adding a negative, yeah, that sign would be, that would count as a negative. That's okay. So I've not changed this function. This function is still the same as this, because I'm adding a negative, which would give me a negative. So this function is the same, but now it's written in such a way that these signs are the same, the signs are the same, and therefore that has to be equal to negative 1. If I put negative 1 in here, this would be exactly the same as this. Everything's the same. That's negative 1. That's the way I like to do it. Okay. And then we're on to doing our tan alpha. So I know that k sine alpha is negative 1. K cos alpha is 2. So therefore tan alpha is going to be sine over cos. But when I do my shift, I'm going to say inverse tan is a half. I'm going to work that out. And this is in degrees, so just check your calculator, still in degrees. Yep. So shift tan of a half, or inverse tan of a half. That's 26. I'll call it 0.6 degrees. This point, you may want to do your cast diagram though, because we're saying, okay, in fact, sorry, no, I'll do a cast diagram just now. So we want to say, well, sine is negative. So where is sine negative? It's negative here and here. Where is cos positive? Because I've got negative sine, positive cos. So cos is positive here and here. And I've also got a negative tan. So tan's positive in these two. So it's going to be negative in these three. So you're looking for your free text, fantastic. So that means that the alpha I'm looking for is going to be 360, take away the 26.6 because I'm in this quadrant. Let's take away 26.6. I said alpha is equal to 333.4 degrees. So that's the first one we've had where it's been a little bit different actually. That's good. I'm glad we've got one of them eventually. Where they've got a little negative in there. Okay. And for 4 we're going to work out the k. So I'm going to say that I've got k is equal to negative 1 squared plus 2 squared. No, I put that in a bracket. There we go. So 1 and 4 root 5x. And then just to finish off, I'm just going to write down my wave function. So there's your 5 steps. Not tremendously difficult. It's root 5, and we said it was a, what was it, sorry, a cos takeaway. Cos x takeaway 333.4 degrees. So that would be the height of my function, and that's how much I've shifted it to the right. Okay. Fantastic. So that was what we did last time. So we should be really comfortable now with this, you know, with the process. And we've even got to see a little negative one. Some people stress out with this bit. That can be a little bit tricky. But if you think about it, everything just has to be the same. So make sure these signs are the same, the signs are the same, the causes are the same, and then it really is just these numbers match up. Okay. So don't overthink it too much. Okay. I've still kept the integrity of this function. That is still a negative, isn't it? That is still a negative. I've not changed that. So now we're going to find the maximum value of 6 cos x negative 3 sin x. Okay, so for part B, I would just start off by saying that our wave function, so root 5 cos x take away 333, 333.4, did I say? Yep. So our wave function is equal to 2 cos x take away sin x. Yeah, we just rewrote this in this form. So now we want to know the minimum value of 6 cos x negative 3 sin x. So let's think. So 6 cos x negative 3 sin x. What have I had to multiply that by to get from here to here? We just times it by 3, haven't I? So if I do the same to this function, if I say, okay, well, if I times this by 3, I'm going to end up with 3 root 5 cos x take away 333.4 equal to that function. Sorry, it's a bit wonky. So I don't know why that's so wonky. So this becomes my maximum value, and it'd also be the minimum value as well, wouldn't it? So the maximum would be 3 root 5, and the minimum would be negative 3 root 5. Okay. And where does that occur? Okay, well, if we take our function, we say 3 root 5, so this will be part of C now, isn't it? 3 root 5 cos x take away 333.4. I said, well, when does that equal negative 3 root 5? That's all that question's asking. And if we rearrange that, I'll say, well, cos is equal to negative 3 root 5 divided by 3 root 5. I'm just going to divide through by this, which means I've got cos x take away 333.4, these are getting worse, equal to negative 1. That makes sense, doesn't it? Because if you imagine the cos graph, you're really just saying, when does the cos graph equal negative 1? Yeah. So it usually meets negative 1 at 180, doesn't it? So if I was to do shift cos, if I was to do the inverse cos of this, I would end up with saying, well, that's going to be at 180 degrees, isn't it? When is cos negative 1? Inverse of cos negative 1 was there 180. So to rearrange that, I'll just say, okay, well, I'll add on 333.4 to that. 333.4 plus 180. Well, that's going to occur at 513.4. Now, that's not quite the droids we're looking for, is it? That's a wee bit out with my 360. So how do I get that into a meaningful answer? Well, if I just take away 360 from that, that gets me back into my zone, because right now, there's 0 to 360. I'm out over here. I need to take away my period, and that'll give me 153.4 degrees. Okay, that's me now back in, and I can obviously keep taking away that number. You can keep adding that number. This goes on for infinity in both directions, 360. But we want the one that's between 0 and 360. Okay. So an excellent question, very similar to what we just did, very similar. The only bit that's slightly new is equating these and saying, well, how much have they increased it by? Maybe they haven't increased it, maybe you just go straight for this number, but in this case they did. And then you say, well, this is the max and the min, and then you're trying to find that x value. And to do that, you're just rearranging, and actually you don't even need your CAS diagram here, because only one value. Okay, we'll try another one on the next video.